Homework pressure? No more. At Spring Library, we explain every topic in simple way. Join the learning family and score high every day.
Two knights in this problem are 88 meters apart, accelerating toward each other. So I'm just going to draw George as a circle over here and Alfred as a circle over here. They're going toward each other with an initial velocity of 0 for both. V naught George is 0, and V naught Alfred is 0. They have different accelerations. George's acceleration is 0.3 meters per second squared. And this is just the magnitude. We know they're going toward each other, so I'm really just worried about the magnitude of the acceleration. 0.300 meters per second squared, where Alfred's, the absolute value of Alfred's acceleration, or the magnitude, is 0.200 meters per second squared. So we want to figure out where they meet relative to George. So we'll kind of show this distance here, as 88 meters. And we know that the distance traveled by George plus the distance traveled by Alfred is equal to 88 meters. So if I look at the magnitude of the displacement traveled by George, I can use the equation initial velocity of George times t plus 1/2 a of George times t squared. So this is our displacement formula. And the initial velocity of George is 0. I can do the same thing for Alfred. The initial velocity of Alfred times t plus 1/2 Alfred's acceleration times t squared. So these two quantities, if I set expressions for them, they need to add up to 88 meters. So starting with George, I know this whole term goes away and this whole term goes away. So I have 1/2 times George's acceleration, so 0.3 meters per second squared times t squared, plus Alfred's displacement, the magnitude of Alfred's displacement, which is 1/2 times 0.2 times the time squared. That all has to add up to 88 meters. So this isn't directly give a position where they're going to meet. It does give us the time where they're going to meet, and that can help us quite a lot. So half 0.3 is 0.15. So I'm just going to simplify this a little bit. 0.15 times t squared. Half of 0.2 is 0.1 times t squared, and that is 88 meters. I can combine like terms because each of these have a t squared, so that would just be 0.25 meters per second squared times t squared, and that's 88 meters. So all I need to do is divide both sides by 0.25 to get t squared. And we get a t squared value of 352 seconds squared. So take the square root of both sides, and we have a time of 18.76 seconds. Again, this is answering the question because we want to know where they meet, not just when they meet. But if we know when they meet, we can go back, and it does ask us to find the position relative to George. So if I use George's equation over here, which is the V naught G, I'll just circle this initial equation that we can go back to right here. V naught G times T, 1/2 acceleration of George times T squared. So I'll use that and plug in the numbers that we now have because we have the time. So the position relative to George is equal to George's velocity initially, which is still 0. Anything times 0 is still 0, but I'll plug it in anyway, plus 1/2 times 0.3 meters per second squared times 18.76 seconds, and this quantity is squared. So our value for George comes out to be 52.8 meters. That's position relative to George where the two knights meet. So a little bit more than halfway. That's